Alright, just going on to the next part of circles, and that's looking at semicircles. Now, we've got our equation for a circle, um, x squared plus y squared equals r squared. If we just rearrange that a little bit, we'll have r squared equals, y squared equals r squared take x squared. And if we take the square root of that, we'll have y equals plus or minus square root of r squared take x squared. It's just a bit of rearranging there. So the equation of the circle can also be expressed as this equation here. Maybe not as nice as this one here, just because it looks a bit bigger, but it's basically the same equation. So when it's in this form, it includes two semicircle functions put together, basically, because of this plus and minus. So one of them, we have y equals the positive square root of r squared take x squared. The other one is the negative of it. Okay, basically two semicircles put together gives us one whole circle. So the semicircle is going to be a function now with a many-to-one correspondence. And why is that? Because if we draw it, okay, and here's my semicircle. This number here is going to be minus r, positive r, positive r. That's just my radius. And obviously, if we do our vertical line test, we're going to have a 1. You only get 1. It only touches it once. And using our relation, if we go, it'll be a many, a horizontal line to 1. So it'd be a many to 1 function now. Okay, it's now a many to 1 function. The domain can be deduced algebraically because square root of r squared take x squared is only real if the r squared take x squared is greater or equal to 0, because we can't get a negative square root. So our domain is going to be restricted between minus r and positive r. Circle with center HK and radius r. Yeah, as I said, we can rearrange that to get. Okay, so we've got a circle with center HK, radius r, rearranging its equation. Okay, we've got this. If we rearrange it, I'm not going to go through it, we'll get a very similar case where we get the square root of r squared take x minus h squared and plus k. Very similar. That's a semicircle which has been moved left or right or up and down. I've just rearranged this equation. And just looking at regions bounded by a circle. So just very quickly here, we've got a circle here, and it might be, we'll just say x squared plus y squared is less than or equal to r squared. Let's say it was x squared plus y squared less than or equal to 4. So obviously a radius of 2. Okay, I haven't been moved left or right or up and down. So what values of that is less than 4? The simplest way to check is to test if 0, 0 is in the equation. So 0, 0, 0 squared plus 0 squared is obviously less than 4. So it's all these numbers in here. So the region is therefore a closed integer of the circle and includes its circumference. So it obviously includes the outside. If it was just a less than 4, we would be a dotted line. So just as a side example, x squared plus y squared is less than 4. Okay, we still have a circle, but we don't want to include the circumference. So what we do is we draw a circle, which is dotted like that, and it'll be all those numbers in here. Okay, not including the circumference because it's less than 4. Okay, same thing, we've got a radius of 2. So all these numbers are the same, except we just don't include the outside. So that's how we do distinguish between whether we include the circumference or not. Okay, and I'll just go through an example in a moment. So example 5, sketch the graph of y equals the square root of 5, take x squared, and state the domain and range. So we've got square root of 5, take x squared. It's equation of the semicircle in the form y equals square root of r squared, take x squared. Equating them, so we can say our r squared is actually equal to 5, and we've got x squared equals x squared. So r squared, r is going to be the square root of 5. And r cannot be negative. So this is an upper semicircle. So if we draw our set of axes, so it should be plus and minus. So negative square root of 5, positive square root of 5, and we've got a semicircle, and this is going to be square root of 5, and that's basically it. And we just state our equation, y equals square root of 5, take x squared. Okay, pretty straightforward. Just find out where your radius is and where they sit. Okay, we haven't been moved left or right, so it makes it easy. Part B, sketch, and we've got 4x squared plus 4y squared is less than 1. Okay, first thing, we need to get rid of those 4's, so dividing by 4. So we'll have x squared plus y squared is less than or equal to, just less than, and it's going to be 1 over 4. Now we've got a circle. We haven't been moved left or right. So if we draw a set of axes, we start at 0 because we haven't moved left or right. What's our radius? R squared is 1 over 4. So we can say R is going to be 1 over 2. Okay, square root of 1 is 1, square root of 4 is 2. Now, we've got an inequality, so we're not going to include the circumference because it's just less than. So we draw our circle, but we draw it as a dotted line. We've got a radius of a half. Okay. And we want all the numbers. Just checking again, 0, 0 is obviously the easiest. 0 squared plus 0 squared is less than a quarter. That's true, so we want all these numbers inside the circle. If we weren't sure whether it's outside or less or inside, we check the 0, 0 because that's easiest to find. If we still weren't sure, we can check 1, 1. So 1 squared plus 1 squared is 2. 2 is not less than a quarter, so therefore the 0.11 does not include the inside the boundary, so it's outside, so we want all the numbers inside, just as a side thing. Okay, so that's part B. Again, pretty straightforward because we haven't moved left or right or up and down. Part C, for the circle with equation 4x squared plus 4y squared equals 1, give the equation of its lowest circle, semicircle, and state the domain and range. Okay, so we want a semicircle, so therefore we need y equals something. So rearranging to get y by itself. So taking the 4x squared, dividing by 4, and then taking the square root of it. And we get a quarter, take x squared. Now, again, we're going to have a center at 0, 0. And that's because it's basically the same equation as we just drew up here. Okay, but yeah, it hasn't been moved left or right because we don't have anything inside brackets, and we don't have something outside the square root. So we want the upper semicircle. Our radius is going to be, well, actually, we've got y equals square root of r squared take x squared. What's our r squared? Again, it's going to be 1 on 4. So r has to be 1 on 2. Okay, and the lowest semicircle would be the negative part. Same thing for r would be a half. Okay, so we want the lower semicircle. I was wondering why it didn't make sense because I'm looking at the example and it's having negatives. But we actually want the lower part. So we actually want the lower semicircle, which is going to be the negative of our equation. Okay, and okay, so our equation's here. Again, we start at 0, 0. We go to the left, radius of a half, so we go to the left a half, and we go to the right a half, and we want the lower semicircle because it's negative, and looks something like that. So our domain is going to be between minus a half and a half. Our range is going to be from minus a half, and so I'm going to get up to 0. Okay, so domain and range are those two. So that's example 5, and we're going to have a look at tangents of the circles in a moment.